Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Today we have quite a few topics, including a smart contract attack, a GitLab issue, and some vulns in Apache Batik. Before we jump into it, though, I do want to note we will be doing some watch party streams of the DEF CON 30 talks this week. That'll be Thursday and Friday at 6 p.m. Eastern, 4 p.m. Pacific. We'll let you know on Twitter as well, closer to that, but I did want to give a bit of a heads up. We
Those
also
will be
have,
on Twitch, right? Last time we did
those
them
will
on
be on
YouTube.
Twitch. Yeah. Well, I think the DEF CON ones we did on Twitch, but the
last
Offensive
watch
Con ones
party
we did on YouTube. Yeah. Also, I'll note that we did get permission to do a watch party for the Hexacon talks as well. So we'll let you guys know when those will be. Likely next week, but we'll let you know next week if that's the case. But yeah, so we'll have a few watch parties coming up, so keep a lookout for that. But yeah, with that out of the way, let's jump into our topics. We'll start off with an issue detailed by ZDI in Apache Batik. So yeah, ZDI put out this blog post last week on some vulns in the Batik library, which is a Java-based library for parsing, generating, and manipulating SVG graphics. As such, it's a pretty interesting library to look at for things like SSRF, but also interesting for RCE because it can execute JavaScript through Rhino and also load and execute remote Java classes. Now, obviously, Batik does try to protect against both cases with external resource controls, where it'll try to enforce some rules. So by default, it'll apply sort of like a same origin policy. So, if you load a local SVG file, it can load local scripts and resources, but not remote ones. If you load a remote SVG file, you can load scripts from the same host or over HTTP or any other supported protocol to that host. But the intent there is you can't just load it from some arbitrary other host. Now, that idea of being able to use any other supported protocol is kind of where this issue comes into play, because they started looking at, okay, well, what if we look at some of the other protocols other than HTTP, like jar. So if you switch to something like jar, the way they do this checking, this validation of the host, is they use the get host method from Java. But on a jar URL, get host will always return null. So it'll kind of think like it's a local file basically. Instead, what you're supposed to use is get file and then get host on that returned object from get file to properly check that host URL. So kind of a straightforward bypass just due to like how jar URLs are handled differently with get host. Jar files can bypass that default external resource security control, and with that, you can either perform SSRF via jar to send requests or NTLM relays or whatever, or a script execution is enabled. You could end up getting RCE through Batik's script execution feature. They go a little bit often do a bit of a tangent on that, into a parser differential type issue that exists in the script allow list. Basically, their allow list is separated with a comma space when being built up, but the tokenizer only uses a comma. And that actually ended up hurting them because while Java archives are in the default allow list, because of that space, they technically won't be enabled. But that's not too much of a problem because ECMA script works. And they point out that ECMA script is interpreted by Mozilla's Rhino, which has a known code execution vector. I'll bring that up on the screen for anyone that's interested. Basically, what I believe they're doing is sorry, that might be the wrong one. Here it is. So basically what they're doing is they're using like a string constructor, invoking the Java runtime exec function and concatenating that into a string and passing it to a val. I don't know enough about ECMA script to be able to go into thorough detail of exactly why that attack works, but it's a known documented vector, so yeah, they're able to use that to get command execution. The main vulnerability here is just the reliance on get host and not being aware of it not really working the same way with the jar protocol, which, to be fair, is really hard to fault them for. This seems like one of those really dumb things where it's kind of fair to pin it on Java itself and their libraries, and not so much on Apache here. And the ZDI post kind of takes that point of view too. But yeah, I mean, it's a bit of a funny bug. One of those ones where it's just the implications of how you invoke the method are not really well known, I guess, or not intuitive. So yeah, kind of bit Apache here in this case.
Yeah, and I thought I mean, just the bypass early on is just kind of a fun thing. I mean, we see that all the time where it's these random, in a sense, just the schema not being validated correctly or not working exactly how you expect. That ends up causing problems.
Yeah, exactly. Yeah, kind of a quick post. The ZDI post does go a little bit more into the details of that other parser bug if you're interested, but they mostly just talk about that to highlight why the obvious of just like loading a jar file to get easy RCE didn't really work, and why they had to take these extra steps. All right, so our next topic is an article by Asset Note on exploiting a bug in the Netlify IPX library, which is exploitable in Next.js websites on Netlify. And it was a bit of a joint effort between Asset Note and Sam Curry. And since we're talking about Web3, it's of course an interesting area and a somewhat unique ecosystem. In this case, they were looking at Netlify's ability to pull and optimize images from remote URLs through the image proxy. And in particular, one particular case where a path where user controlled input could make its way to such requests through X forwarded proto, which was used to build up the a protocol variable. So, kind of calling back on earlier episodes, X forwarded headers are very interesting for seeing where you can get controlled data into places that you might not expect. Um, they then did some checking on it, trying to. So yeah, the code would then like check the URL that it would build up using that protocol variable, and it would try to see if it was a local file or not by seeing if the path started with HTTP. Um, Notably, if it was a local file, it would basically skip any whitelisting checks or any validation on the URL. I guess since it assumes that it's a local URL and is safe. The problem is because the protocol can be set by the attacker, which is used to build up the ID string, you have control of that string from the start, and thus you can basically trick the handler to assume it's a local path, and just get around any of that validation that might have been happening on the URL.
Yeah, if I
Um,
can jump in quickly. I guess
yeah, go
part
ahead.
of that, like it only checks let me scroll up here. How the URL is actually crafted. You'll see at the very end if you provide the URL to whatever image it's supposed to proxy to. So this is being used by like static site generators. They'll have their images and point it to the image optimizer. That way it can proxy to a backend serving it or and have caching and all of that fun stuff. Um when it would check if something's local, it would only check that last bit, and that was without the protocol. It wouldn't create the ID with the protocol until after it did the local check. Um, the way you kind of phrased that made it sound like that was happening earlier, but it happens afterwards, and it's just assuming whatever protocol was used is the safe protocol to use. Um, yeah, it only kind of validates on the host.
Yeah, fair call though. So yeah, it'll end up reaching this load source image function, which will then fetch the resource and cache it to disk. The thing that makes this a little interesting from an exploitation perspective is that, obviously normal image files won't really be super interesting, even if you could fetch them from an attacker server and get them cached. But due to the use of IPX, SVG is supported and can be cached. And, we've talked about SVG a lot recently because it can be used to get code execution. So yeah, that could basically allow them to achieve persistent cross-site scripting on any number of sites that are using Next.js with this trick. So it's a very wide and impactful attack. And as I always bring up when we talk about the crypto ecosystem, there's a lot of potential for damage there. So definitely a good thing to catch. They do go into a bit of detail on a slightly different issue towards the end at Gatsby.js. Sort of like a variant analysis, similar issue, though not quite the same. There they were looking at the Gatsby file route, where one of the routes would allow you to proxy any URL regardless of content type in one case, and in another case you could proxy images as well, though not SVGs like the Netlify bug. But to exploit that issue, Gatsby would have to be running, which they note is an uncommon configuration since it's a static site generator. In production, the server shouldn't be running for, or Gatsby shouldn't be running for an attacker to be able to pull this off, really. But they do mention it, so I thought I'd call it out. But
Yeah, I
yeah, I
mean
mean
it
the first
happens.
issue. Go ahead.
I've seen it where people run like the um I don't think when I've seen it, I don't think it's been Gatsby, but the idea in general, a lot of these static site generators will have a development server that does like auto refreshing and stuff, making it really convenient to run while you're working on it. And so sometimes you will run to the odd setup where what they'll do is they'll run the development server as the service and just like reverse proxy to it. Not a good idea at all because these development servers generally aren't written with security in mind. They're written with convenience for the developer in mind. So not a good thing to do, but I've definitely seen it. I think I've seen it with Jekyll more, but that's purely just what I've seen. I can imagine people doing it with any of the static site generators. If the functionality's there, it's less of a pain to get some things like images and stuff being passed around. There are a bunch of things that it can make a lot more convenient. So it happens. You might not even notice when it happens. Um, yeah, I mean it's worth checking for the endpoint. I mean that's just one of those things you could toss on to a word list if it's not already in there. It's just like a endpoint to look for the Gatsby one.
Yeah, a lot of static site generators will actually like give you pretty colored messages telling you do not use this in production when you run it
That too,
in the
yeah.
development mode. So yeah, I mean, some people ignore them and still deploy it like that, but you're not supposed to. So you'd kind of have to rely on an insecure setup already to be able to exploit that second issue they talk about. But yeah, I mean the original bug they talk about in Netlify is kind of an interesting one, and the impact is pretty high there. So
Yeah,
pretty good that it was found here.
I thought these were interesting just because of the fact that these are, in theory, static websites, which you generally think of as just, hosting their HTML, hosting their images, and not much more. So, especially the IPX aspect for the image optimizer, like it makes sense that, that is just not a new attack service, but another attack service that actually is dynamic on. I mean, granted, these are running generally like they'll say on the edge or like a serverless function sort of thing. So what you can compromise with that, I mean, XSS obviously attacking the client, but attacking the host, you generally don't have a lot there. Like if you were to get RC in one of those functions, which they don't do here, but if you were to do that, you're not necessarily compromising much because these are very temporary, ephemeral instances. Uh, it's just interesting to note the attack surface there. You might be tempted to think, oh, this is a static website and just move along, whereas there can be some of this functionality that isn't so obvious.
Yeah. So continuing on the crypto issue train, we have a smart contract bug which was exploited in the wild to steal $220,000 worth of crypto assets. Z, I'll let you get into this one.
Yeah, this one kind of interesting because it's as the title kind of indicates here, read-only reentrancy exploit. So if you're familiar with crypto, reentrancy attacks are kind of one of the big ones. They're really one of the classic bug classes within crypto. If you listen to our binary episodes, we'll sometimes talk about in the Windows kernel where like you'll have a function that's executing, it has a callback in userland, and then userland like messes things up. And when the kernel starts up again, the state will be messed up. It's a similar idea with reentrancy attacks on smart contracts. The contract passes off um, control to another contract, and that contract uh, basically does something unexpected. For most smart contracts, it's calling back into the original smart contract and starting to change state while in the middle of another state changing thing. Um, if I didn't explain that too well over audio, you can probably, Google this up and you'll find plenty of things kind of explaining this sort of attack. But generally speaking, what you want to do is you want to protect all of the functions that are externally callable that are going to modify the state in a smart contract. You want to protect them, add a reentrancy guard on them to say, hey, don't allow contracts to reenter. So it can end up calling out. And so I guess one other important aspect when it comes to smart contracts is just the fact that everything's kind of single threaded. It's just running this transaction, all the code that it needs to. And when it transfers funds out, the recipient contract will have a chance to start executing their own code at that point in the transaction. That's how attackers can kind of start running their own code in the middle of everything. So coming on to this one, it's in a read-only thing, so it wasn't protected by the reentrancy. And that's because the real vulnerability kind of exists in it does exist in this curve LP smart contract, but it's also kind of taking place outside of it in market XYZ, which is another thing used to like swap coins. So curve LP provides a oracle, just say here's what the cost of our tokens are. And so with that is a little bit of background. Hopefully things will kind of make sense as I finish this one up. But you've got the remove liquidity. So an attacker might add funds into the pool using add liquidity. They'll do that and then they'll remove it. And in the removal process, what it does is it will update the total supply of like how many tokens are in the liquidity pool, curve LP, curve liquidity pool. It'll update the total supply, and then for all of the coins that need to be passed out from that, it'll iterate one by one, effectively. For those of you watch, I apologize, my highlights can't line up on this one, but it'll update just basically in this for loop, for I in range and coins. It'll go through and it'll update the balances every time, saying like this one, just updating the balance amounts, and then does this raw call. That's where it's sending it back out to the receiver or the attacker in, an attack case. And so at that moment, an attacker, gets control of what code is running. And at that moment, they've updated total supply, but you'll see at the very end, they update this D, and these balances are still being updated kind of with each iteration. That's where you kind of have the issue come up, because the balance amount, which influences that D value at the end, and that's influenced by the balances, whereas the total supply has already been updated. So you have this desync where it's not done updating all of the balances, but the attacker's still got control and things are going to change. So there's this price oracle. I'm just looking for the function name here. Might have been in the other post.
Yeah, I don't see it in this one.
Yeah, so get virtual price. And what happens with that one is, calculating get D based off of balances. And the token supply, and it does its calculation based off those two values. So token supply is correct for what's actually in there, but balances has not finished updating at this point. So any other contract that calls in to get virtual price, and this is just the price oracle, here's what the token is. Any other contract that trusts that value will get an incorrect response at this point. So what they did is the market XYZ, which is going to check like, hey, how much are these tokens worth? And so it goes and, get virtual price, and it's going to get an incorrect price. And so an attacker is going to be able to execute the market XYZ contract, which calls in to get virtual price, with basically manipulated price in their benefit to start stealing tokens that way. So it's kind of interesting because you need that third party, you need that trust. It's a price manipulation issue. But I thought it was interesting just because of the interactions going on here.
Yeah, you're basically able to use a flash contract to borrow using like an inflated price, which is how that attack worked. I think they mentioned there was actually 2 attacks of this issue that they noted. I'm just trying to find exactly where that was. Attack 1 and attack 2. So they detail the addresses there. But yeah, I mean, one of those crypto issues where like reentrancy is only seen in a few different places. You don't really see it super often. One place is, like you mentioned in the binary episodes, with something like Windows, where they support those user mode callbacks. Sometimes you get reentrancy type issues in like JavaScript, but for the most part, you only really see it in crypto. It's a classic crypto issue. Whenever you start looking at like crypto security research, it's the first thing that pops up, basically. There's protection introduced very early on for it. But like you were saying, like read-only reentrancy is kind of an even more rare attack class. Just because usually when you think of reentrancy problems, you think of tainting the state, not so much of like an outdated state becoming a problem, which is kind of like what's happening in this attack. So yeah, it's a bit of a complex flow in how it works. But it obviously worked out for these attackers, and they were able to do a lot of damage with it. Not quite as much damage as we've seen in some other smart contract attacks, but yeah.
But still, I mean, something for like, they still got away with a good amount on it. Pass it all into Tornado Cash, and away it goes.
Yep,
I will
home
say
free.
it kind of does showcase though, like the whole issue with reentrancy attacks. Like it is the iconic attack in smart contracts. Um, it feels almost like memory corruption when you're using like C and stuff. It's like it's one of those issues that always and every time you write and see it turns up. Somebody's writing the bad code, and it just feels like there should be. I guess there probably are other languages that are trying to tackle that, but I don't know. I don't know how much we want to go into that discussion either, or also, but I don't know. It feels like they need to take more steps towards preventing and like having that protective mitigation against these sorts of attacks. That's more than just the developer needs to remember to put a reentrancy guard everywhere. Like it feels
Yeah,
like
it's like
something
playing
that
whack-a-mole.
Yeah, it feels like something that could be approached in a more central way. And I believe some other languages that you can use with smart contracts will actually prevent the reentrancy in like all cases pretty much. But um this isn't an area that I've done a lot of research in, so I could be mistaken about that. But yeah, I don't know. It feels like, having these reentrancy things is kind of like the memory corruption class of issues with C and C++. Like, as long as you're using these languages, you're going to keep having them.
Yeah. And in the crypto ecosystem in particular, like smart contracts, where you can keep exploiting the bug over and over again until the service is taken down or something. Um, you know, the impact is higher, like a lot higher there too, because yeah, you can just keep using it to take more and more money until it's noticed, basically. Um, so yeah, in this case, they made off with a couple hundred grand using the Curve LP Oracle attack. A bit of a complicated attack. Apologies for anyone listening if they weren't able to closely follow it. Um, it is one of the occupational hazards, I guess, when you're talking about smart contract type issues. They do tend to get more complicated, but
It's got a more complex control flow to it because you're leaving the
yeah,
contract, you're leaving both the attacker and the service and going to a third party victim.
yeah. But yeah, the post is there if you want to take a look. I do recommend reading the other write up that Z brought up on the stream. I feel like this Medium post, it's not super easy to follow, especially if you're not super into the smart contract ecosystem. It kind of like hand waves and assumes you already know what's going on in certain areas. Whereas I think the other write up does a bit of a better job breaking things down and showing things, particularly when it comes to like the price oracle. But yeah, cool bug
Yeah,
nonetheless.
I
It's
think the
unfortunate
first,
that it was exploited in the wild, but it's just how it goes sometimes, I guess.
yeah, but it gives us content to talk about.
What's
Um,
that?
oh, I said, but it gives us content to talk about.
Yeah,
Although, so
true.
would just disclosing it. Yeah, I'll say the second post thing kind of explained the core issue better. The first one did a better job just talking about the big picture.
Yeah. All right, so we'll get into our next post here, which is from GitHub Security Lab on some weird vulnerabilities in load balancer, shallow copies, and caches. Z, I'll let you take this one away as well.
Yeah, and I don't think this is GitHub or the security lab.
Oh, sorry, my
This
bad.
is
I jumped
just
ahead. Yeah,
yeah,
this was sorry. This was a
this is
Medium
just
post.
medium. Um, but yeah, this one is honestly, I don't know what the full takeaway from this one's going to be, but they were weird bugs, so I did want to call these out. Um, and I'm actually just noticing now. I just saw this post, but apparently this is from 2020. So apologies for having an old post in here. Usually try and keep them within a week, but I just saw this one. I thought they were really weird bugs. So basically, what he found were load balancer issues. Um, Effectively, the load balancer and the HTML and certain script blocks would just return like a user ID of current visitor, and it's like that's not his or that's not his ID, or that's not his email, and it would be returning other users' information in there. And this happened in a few different places, like this whitelisting, this form, or as it's generating it. One of the places that he found it that I thought was most interesting was in this it doesn't show the URL, but in this one request, the response is basically just some JavaScript that sets their update login header. So basically sets their authorization header for making like API requests. So when that's caching for another user, and it would only give this cache version when you had no session cookie. When that gets cached for another user, it's leaking their authorization header. So you can basically take over. Well, they don't talk too much about what you could actually do with the API, but presumably you authorize as that user, and it's a fairly significant bug. So I thought it was interesting just to call out these sort of caching issues. Don't see them a lot, but also not necessarily looking for them a lot. So just some to kind of be aware of, I guess. They talk about as like the actual problem having been due to a shallow copy of an object in the backend, an object with references, customer data was cached. When the object is returned, the vulnerable page is rendered with multiple instances of customer data, sounding almost like a sort of use after free-ish issue, or like, dangling pointer. I'm not exactly sure
funny.
what's going on there. Like, it does almost sound like their load balancer has some sort of binary issue, but they don't dive into it. And so we can't really go into it either, but it's interesting to see these sorts of caching issues. Hard to kind of test for. On that note, though, the authorization one, it was keyed, or at least part of the key for that cache entry was a lock parameter in the URL. So they could actually abuse that by sending their victim this URL with a random lock parameter, and then when they would later access it, they'd get the cache version back with whoever their victim's cookies were, or authorization header was. So that one was much more substantial. It's just, these are very weird bugs, and that is the only reason I wanted to call them out. There isn't a lot to say here, I don't think, because it either
really
happens or it doesn't.
And that as well, yeah. Yeah, kind of interesting how the attacks can work out though, and what you can do with them. They're kind of neat. It's unfortunate there's not like a lot more detail there, and also that it's a bit older as well. Though, I guess if there was a takeaway that we wanted to highlight here, it's just like, I guess, test for weird things, which
not test, but
doesn't
look
matter
for it.
Yeah.
This is something you could very easily overlook unless it actually breaks functionality, which it might in some cases. But it is one of those things that, I guess in this case, like, his testing did involve removing cookies and still getting some cached information back. So there is that aspect to the testing, but it's more just one of those things that you're not going to notice unless you're actually paying attention for it.
Yeah.
And so that's where I feel like, at least calling it out as something to keep an eye out for. But yeah, I mean, really, either it happens or it doesn't. In this case, you're not really easily able to cause it to happen.
Yeah. Your control is pretty limited there. All right, so we'll get into our next post here, which is, this one is from GitHub Security Lab. It's the one that I got confused with the last topic. And yeah, this was a post that was made last week on a bug in the task.org Android app, which is an open source reminder and to-do list tracking app. The bug is is basically a path validation issue in the share link activity share intent, which can accept paths to attachment files to copy into the app's external storage directory. The kind of funny thing is that path can be arbitrary, and there's basically no validation on it. So you can end up sending intents with task.org's internal storage files and get the share link activity to copy those files into an external public directory for you, such as the database or preference files, which can contain sensitive information, including like the CalDAV integration credentials, if that's enabled. Though passwords are encrypted using KeyStore, so that's somewhat of a mitigating factor. But yeah, it's just kind of a funny attack, because you can basically just ask the app to share its own internal files to an external storage directory, because they don't validate the path that you provide against that. So yeah, it's just something that wasn't really thought of, I guess, when they were handling the intents. And as such, it's a somewhat straightforward issue. There's no crazy bypass shenanigans going on here.
I mean, not thought of. It's just the sort of thing that this does happen. It's one of those things where they wrote the code the easy way. Oh, you want to share a file, you must be sending us the file you actually want shared, and just not really considering that a malicious application can trigger the same thing, can send that intent. And so they wrote the code the easy way, not really even considering that these things could be malicious, which in fairness, a lot of devs do. I thought this was an interesting post because it really is uh symbolic, I guess, of the normal type of issue you look for on mobile testing. Like I see a lot of people ask, like, how do you get into looking for bugs on mobile applications? What type of bugs are you looking for? And these sorts of like permission issues are one of the key issues that you find. Just in this case, access thing. We've seen other ones like uh I think it was maybe Safari, might have been Firefox. The APK would basically let you craft URLs that would leak the internal files like cookie storage and stuff, and read those. So you see these sorts of issues quite a bit. So that's why I thought this one was interesting to share, not because the bug is super interesting or unique, but because it is a good example of mobile bugs and the type of thing you should be considering because you're generally not like, yes, you can have memory corruption in them too, but generally a lot of the bugs are these higher level things.
Yeah, these more logic level issues, which at least for like mobile applications we don't cover quite as much.
You
So
don't see them as often. Like I don't
they're
see
not as like
write-ups on
flashy, I
mobile.
guess.
I don't see people writing them up all that often, whether that's just because they're not hunting for them or they just don't think they're interesting to cover. And I mean, I guess in fairness, there are a number of times where I just don't think the bug's interesting to cover also.
Yeah. But yeah, this one I thought was just kind of fun because, like I said, it's that idea of like asking the app to share its own files. Using the app against itself essentially. Though the impact is somewhat small. Due to things like the password being encrypted, there might be some other useful credentials in there. Maybe for pulling off like some second stage attack or something. But yeah, on its own, it doesn't seem like the impact's super high. But it is an issue. You can share those internal files. Um, which Android, tries to permission off. So
Yeah,
yeah,
it's not super sensitive in like the global scheme of things, but for what task.org does, it is.
yeah,
Like
yeah.
it's
It's a good point
probably
actually.
yeah.
Because it's like a reminder app, there could be some sensitive information that people are putting in their lists or whatever. So fair point. But yeah, we'll get into our last topic here, which is a GitLab HackerOne report. This netted a 22K bounty and was used to import the GitLab CTF project to get a flag, which is kind of neat because it's the first time Z or I have seen that. Actually, I'm pretty sure.
I
At least I
think
don't think
this is
we've
the
covered it before.
I think this is the first time the GitLab flag has actually been captured.
Yeah,
Oh, so there are other bugs that could have like captured the flag technically. But this whole so if you don't know what we're talking about, what GitLab does is they have a group and repository that is specifically for kind of proving auth bypass issues have like a more substantial severity, because generally speaking, just being able to say disclose a file or something's auth bypasses aren't necessarily going to have a very highly rated CVSS score, but they might be able to access. Like for GitLab, being able to access other users' repositories is kind of a big deal. Like that is critical data for what their application is. It's very important to what their app does. So even though the CVSS might be low because it's just an info disclosure or something, it has a much more substantial impact because that is their business. And
it's
so they
very
have
it's central to their threat model, basically.
yeah, so they have this capture the flag where they have this repository. They have all the information, like here's the the group ID, the project ID, all of that is made known, and just basically capture the flag out of that repository, and you get 20,000. And they do indicate that this is just the first person to do it gets 20,000, and then after it's been captured. We will pause the program for a bit, and then re-enable it later. That's why I believe this is the first time it's been captured. Because this was just in August 2022, so kind of makes sense. A few months later, actually, when was this one reported? Disclosed on the 3rd.
I believe it was
reported
reported
August
in
30th, so
August.
actually just within a week of them starting it. So very close when they start. So yeah, this is probably the first time it was captured. But yeah, Rudimal kind of hits on thing. I like the flag idea. Haven't seen that before. I've often complained about CVSS not necessarily being a great way to score vulnerabilities because it doesn't capture some of that business impact. And so this is a really great way, I think, to tackle it. There have been other bugs, like maybe an RCE that doesn't qualify for this because just getting code execution, they're already paying out well for that. Whereas this, the final bounty was $22,300. But that's with this 20,000 bonus. Like the actual bounty on this would have only been, I think
it was an
$1,800
bounty. Yeah,
1,800 bounty plus a 500 for triage. Just for on the initial triage. So good bounty. But anyway, we've talked all about the meta aspect. For what the actual issue was, in performing a bulk import, you can provide the HTTP URL of your target repository. And they would take that URL and create the variable for it, add in, or they would make a call ultimately to the GitLab URL blocker validate function, which takes the URL, has a couple other variables being passed in. Some they're not passing in is the whitelist of schemas. So what ends up happening is they can use the file URL and import any of the repositories that exist on the local file system, as long as they could craft a path to it. And the actual path for any project is just based off of a bucketed SHA-2 hash. So like you'll see the folder B174, the first couple bytes of the path, and then the rest of the SHA-1s kind of bucketing them a bit, and then the actual repository going just with the hash. So it's a deterministic thing. There's no randomness to figure out. As long as you know the project ID, you can figure out where it's stored on the file system. It does need to get through this URL blocker validate, though, which is the one place I do have some questions about how this works, and I didn't entirely figure it out. Since they're not passing in the scheme, they're able to provide the file URL. So that makes sense. They're getting something on the local file system. What they end up using was file // aw.rs/ and then the path to whatever they actually wanted. What's confusing me is the presence of aw.rs. That is needed for the host validation. Basically, the URL blocker will take a look, do some validation of the host. Of course, in this case, like they can't provide any host, so whatever, but it needs to be able to parse something. So they use the domain they actually controlled, but they're accessing the local file system. And so this doesn't quite make sense to me why they're not accessing like root aw.rs/var, like why this isn't being treated as one complete path. The only thing I can kind of figure is usually when I see these file URLs, what I see is file : / with 3 slashes. So maybe that one is usually or somehow always getting parsed out. I did give this a really quick test just in Firefox for myself. And what would end up happening is Firefox would just ignore anything you wrote there and treat it as though it's a root directory. Just the guy 1, 2, 3, 4, 5, 6, 7. There's very likely a filter on that. That's what usually happens. Do you mean like a filter that's removing it, or? Because that's kind of what I was seeing when I tested with Firefox. It seemed like it was just removing it. Although testing with curl, it was just rejecting it. I didn't set up a Ruby REPL in part because I kind of dislike Ruby and hate trying to write it to actually test anything with it. And in part just the hassle. So I did Firefox and curl to play around with it. There is something going on with that. This did work. Like ultimately this worked. It was fine. Just the guy filter checking for a particular type of URL. But yeah, it is looking. It has to start like that. I totally get the fact that it has to start with aw.rs. The issue is why it does aw.rs/var oft resolve to the local file system var oft and like the rest of the path. But yeah,
Yeah,
like it needs to be in there to pass validation. That is something the URL blocker checks. But when that gets past the git fetch, that's where it seems a little bit weird that it's suddenly dropping that part of the path to me. Like I said, it does seem like, at least when I tested with Firefox, it would just ignore whatever you wrote there. Um, and
yeah, it
so,
seems to be one of those things where the RFC isn't strict on it, and it's kind of like there's differences between different parsers and implementations, and perhaps that's being taken advantage of here. I'm not 100% sure either, but yeah, the fact that it's like only the double slash and then the aw.rs makes me think it's like a parser differential type issue. I'm just not exactly sure how that plays in here.
yeah, so I want to at least call that out because that is a question I have. Obviously, it worked. He got through with this, so great. It works. Um, I just don't entirely understand how. I guess I should have tried by just, using get fetch. I don't know why I necessarily need to go through Ruby. But it is calling get fetch, so maybe I should have just done that. My bad for not digging quite into that enough, but yeah, that was the only weird thing. I often see this with 3 slashes, which resolves out, and that makes sense to me. This one didn't. Interesting little trick if there is something more to that, though, if you can use this in other places.
Yeah, for sure. It's worth looking into, I
Yeah.
think. But yeah, I mean, in this case, like the main problem is just the fact that you can pass like the different schemas. Um, And yeah, I mean, it's cool to see that someone was able to get that flag. And jumping back a bit earlier, yeah, I think the flag idea here is cool too, as a way of like demonstrating impact. I guess like it has been done in some other places, like KCTF kind of works like that too. It's sort of similar, but
True. I
yeah,
feel like KCTF, though, I don't know. I mean, yes, it does do that, but KCTF is more using it as a way of proving you actually like did the full exploit.
that's true.
Whereas
It's a little
this
bit different in
is,
how it's used.
yeah, this is used more to bump up the reward on what would otherwise be a lower rated vulnerability. Actually, I think let me pull up the GitLab issue itself. I think they kind of call us out that it would have had um, a lower rating. Yeah, the reporter demonstrated the ability to import arbitrary projects, clever trick, and the priority 1, severity 3 labels are odd here because it would normally be rated by CVSS, and here it's fairly low because it's only confidentiality. But because it's important data, it gets bumped up, which I think is the right move. Like, it is important data, and a lot of companies don't take this into consideration. So I like seeing that. And that is kind of the different aspect, I think, between how KCTF uses it and what they're doing here.
Yeah. Um, I was actually taking a look towards the latter half of that comment that you pulled up. He notes that reproducing the issue takes a few tries, as the reporter noted, which I didn't notice before. That's actually kind of an interesting aspect to it. That it's like it takes a few tries, indicating there's some like reliability issues. Um, yeah, I don't know. It's a little interesting. And then there's a reply further down that kind of touches on the aw.rs aspect. So I'll just read that out for anybody listening. Note that in the reproduction steps, the reporter uses the domain file aw.rs var opt. Aw.rs is owned by the reporter here, but it actually doesn't matter for the reproduction, and you can use example.com as long as it's a valid external domain to clear the HTTP validations. Okay, so the aw.rs part, just kind of clarifying there, that could be anything as long as it's like a valid domain.
Yeah, that's what I
Doesn't
was
really touch
saying
on
with.
why it's getting stripped out, but I guess it's a little bit a little bit of clarification there. But yeah,
Yeah, I mean, that's what I was saying by you need to have the URL there to pass that validation in, the URL blocker validator. Um,
Yeah.
but yeah, just unclear on how it's resolving. That could just be something with the file schema that I just don't know off the top of my head. Like I said, usually I would just see that with like the triple slash to go off to the root directory, and away you go with that. I've never really even thought about the fact that you could or maybe would have a host name in there. Like that seems just why.
Yeah, it is weird.
Like, but in being consistent with other things, it does kind of make sense that it would be there. I guess the URI isn't technically just, web things, though we usually see it for that way. So there is probably something with that where it's like, well, this is a file, so we don't care about the host sense getting stripped. But yeah, I mean, it stood out to me to have a host in there. But yeah, I mean, on a whole, cool bug.
Yeah. All right, so that's basically all of the topics that we're going to cover for this week. We do have a shout out. This was a post by Doyensek on a Visual Studio Code Jupyter Notebook RCE. We're shouting it out because it's exploiting an older bug that was found last year in August of 2021. This post kind of talks about more of the exploitation aspect of it. I don't remember if we covered that bug on the podcast. I don't think we did. It was basically like a
I remember
XSS
us
ARB file
covering
read.
some Jupyter bugs. I don't remember if it was the VS Code one specifically here.
Yeah.
I think it seems fairly straightforward where it's text marked out, like just as data thing where you can have the code in there. But on the exploitation side, the original report in there mentioned I could not find a way to leverage this XSS primitive to get code execution. And so that's what this post takes on, because this lands inside of a sandboxed frame and trying to leverage little things to work their way up to actually accessing the what's that object? Basically getting code execution through Electron, through node integration being turned on. We've talked about that before, but effectively, Electron applications, you can get RC if you can communicate with the host, e.g., having node integration on. So,
Yeah, it has a powerful native API. So
yeah. So that's what this post is about. I thought it was kind of a neat read, but also very specific to this. So, yeah, giving it a shout out.
all right. But yeah, that's everything that we have for today. Thank you everyone who tuned in as always. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. Previous podcasts are also up on Spotify, Apple Podcasts, and more links on Anchor. Also, feel free to join our Discord and follow us on Twitter. Links for those are down below or in the chat. Once again, we will be doing some DEF CON watch party streams. That'll be on Thursday and Friday at 6 p.m. Eastern, 4 p.m. Pacific. And closer to that, we'll let you know exactly what talks we're covering and send out notifications for that. So just keep a lookout. And yeah, we'll be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific. And we'll see you all then.